Hello everyone, welcome to the Tech Tuesdays webinar on MDM architecture design, environment scaling through HA and DR setup. I'm Rinda hosting this webinar. Today's presenter is Atish Mahajan, working as a product specialist in different MDM product lines with over 7 years of experience. Before we start this webinar, here are some housekeeping tips. This webinar is for 1 hour that includes a 45 minutes webcast, and then we'll move over to live for 15 minutes to answer your questions. The dial-in participants will be muted so that the presenter will be able to present without any kind of interruptions. The recording will be available in the Informatica Support YouTube channel and the Success portal. The link will be emailed to you as well. The questions can be submitted through the Q&A box, and we will try and answer them to the end of the presentation. You can also post your feedbacks and suggestions in the post-webinar survey and suggestions for the next topics in our upcoming Tech Tuesday webinars. The Tech Tuesday webinar is a webinar series introduced within the Success portal. The Informatica Success portal is a microlearning platform that offers free and unlimited learning to all registered users. The Success portal will show up your success offerings, your customer success manager information, bookings available in the Ask an Expert session, and customized recommendation and content. Here are some important links that you can go over later that will help you in your product adoption. Over to you, Atish. Thank you.
Hi everyone, good evening. In today's Tech Tuesday webinar, we are going to look at the topic MDM environment scaling through high availability NDR setup steps. The agenda for today's webinar is overview of high availability, what its purpose is and why it's needed. We are also going to discuss the different high availability solutions that MDM supports. HA for Activos server and process server, infinite spin clustering, which MDM internally uses to support high availability, Elasticsearch clustering for high availability. Then also we are going to discuss HA requirements for CIF and REST-based application and E360 application. Then there is also JMS and the EJB clustering high availability for the same. And in introduction to the DR and the DR steps and the setup. And at the end, we are going to go through the best practices. HA provides maximum flexibility to access the MDM services without much interruption. So that's typically what is expected out of HA is we should be able to access the services without any interruptions. Its setup helps preventing unplanned downtime. And also it helps to recover from the failures in application components and system-wide failures. So when we say application components, it means that if one of the hub server node goes down, then there are other hub server nodes available to access the MDM services. And system-wide failures, depending on the different high availability solutions that MDM supports, even the lane failures or the network failures can be handled. One way of looking at the high availability is to meet the business load requirement. So if there is a heavy load coming in, then high availability setup, the multi-node setup, the request could be load balanced across the nodes to achieve the high availability through environment scaling and multi-node setup. So there are three MDM high availability solutions that we are going to discuss: non-distributed HA, distributed HA, and zero downtime. Non-distributed HA architecture. So it involves basically multiple hub server nodes and the process server nodes on the app server cluster. So that is what we can install n number of hub server nodes and the process server nodes on the app server cluster. Then also involves the load balancer. So load balancer usage is to load balance the request across the multiple hub server nodes, and also if one of the node goes down, then the load balancer can access the MDM services through the other nodes which is available. Like how we have app server cluster to provide the high availability for the MDM services. Similarly, for the database to be highly available, we have DB clusters, right? So similarly, more than one nodes, if one of the DB nodes goes down, there are other DB nodes available, which application can use to access the database. Now the pros is it's very cost effective, easy to set up, and it's the most commonly used architecture. The cons is if the failure occurs, there is a possibility of single point of failure at the network layer, or the LAN failure is there, then uh, this solution doesn't remain highly available anymore, because though we have multiple nodes, since there is a chance of single point of failure, the MDM services will not be accessible. The DR setup is not possible through this particular solution. Now, second is the distributed HA architecture. So in this particular solution, we have an active instance. However, we also have a passive instance available. So this active instance is same as the non-distributed HA architecture, where we have multiple app server nodes, where hub server is installed, and also we can have multiple, if you have some custom applications available, web applications or the custom services, that also on the multiple app server nodes it can be installed. And also for the DB cluster to be highly available, we can have the more than one DB nodes available. However, in this particular distributed HA, apart from the active instance, we also have a passive instance, right? So the reason for this is if there is a single point of failure occurs at the LAN, and the active instance, the complete active instance is not available anymore, then we have a passive instance available to access the MDM services, right? So the load balancer is responsible to start sending the request to the passive instance as soon as the active instance, there is a complete failure in the active instance. The second thing is the DB replication is required from the active instance to the passive instance. Generally, it would be log based replication. Why it's needed? Because when the active instance is working, whatever the changes that's happening in the database, it has to be replicated into the passive instance, so that when the passive instance is used, it has access to the up-to-date data, right? Now the pros is, as I said, it handles the network failures. It's an ideal setup for the disaster recovery. The cause is high cost and maintenance. The reason is, apart from the active instance, you need to have infrastructure and resources for the passive instance. Then we have a third, which is a zero downtime. This is specifically used even when there is a need to support continuous operations to access the MDM services even during the planned downtime, such as upgrade. So it is typically the active passive distributed HA architecture which we just discussed. However, in terms of replication, it is specifically the real time replication, and Oracle Golden Gate is required to manage the data replication between the environments, the active passive environment, right? So typical steps involved are pre-release, where we have the active instance and the passive instance, which we discussed in the distributed HA architecture. Now, after that, we apply the release to the passive environment, which is basically the upgrade of the hub server and the process server. Now, during this time, the replication is halted on the passive environment, which means that whatever the changes that are happening in the active environment are queued during the upgrade when it is happening on the passive environment. Once the upgrade is done, then all the messages that were queued, all the changes that were done in the active environment and queued will be synchronized with the passive environment. Now the swing environment step is basically the active becomes the passive environment and the passive becomes the active environment. Now the apply release, which means the upgrade of formerly active environment, is also done, and post that we have the upgraded both active and passive with the upgraded versions. Now the pros is it's useful for mission critical apps which cannot afford downtime even during the upgrade process. The cons is it involves very high cost because of the different components to be available, like Oracle Golden Gate is required to manage the data replication. And one of the more cons is it's this zero downtime solution is not available for the SQL Server. So now we are going to discuss the below MDM components, which how it is configured and how it provides and support the high availability for the complete MDM solution. For example, the first is Activos and the process server. So hub server uses the Activos to for the approval workflows, right? So when the users perform any changes, it can go through the approval process, right? So since we have multiple nodes on which hub server is installed, similarly the hub server, when it is going to use Activos, for Activos to be highly available, what all the configuration needs to be done and how it provides the HA. Similarly, the process server is used to execute the batch jobs, right? So for the batch jobs to be executing without any interruptions in the multi-node architecture, how that configuration is done and what are all the steps involved and how it provides the high availability. Similarly, the InfiniSpan, which MDM internally uses to replicate the metadata, we are going to discuss in detail how it is used to support the high availability in the MDM solutions. If MDM is using the smart search to perform the free text search, then behind the scenes the Elasticsearch is used. So for the searches to be always accessible, the underlying Elasticsearch clustering has to be done for the ES to be HA. So we are going to discuss that as well. Now next is the SIF and REST based application. What are all the HA requirements for that? We are going to discuss that. Now E360 application, for it to be highly available, there are certain requirements. So we are going to discuss that as well. And at the end, we are going to discuss the JMS and the EJB clustering. So for the Activos HA, there is one thing from the hub console, we need to register the workflow with the localhost, right? So why it is? Because when the hub server is installed across the multiple nodes, like how it is in the JVM1 hub server is installed and also on the JVM2 hub server is installed, there will be always Activos. Activos will also be part of the same JVM, right? So you have all the enterprise application installed on the same JVM, right? So if we can register the workflow, Activos workflow with the localhost, so that, or the register the workflow in the hub console with the LB URL if localhost is not allowed, right? So basically, if the hub sends a request to the Activos through the LB, then LB can either send the request to the Activos which is on the JVM2, or it can send to the request to the Activos which is running on the JVM. So that LB is the one which will be when, if let's say the Activos is down, then it can access the Activos on the other JVM. So LB is responsible to forward the request to one of the Activos server which is running on across the nodes. Now, however, if we register the Activos with the localhost, then each hub server can access the Activos which is running its own JVM. So this is the way so now, since already the hub server the requests are already load balanced, which is coming from the clients. So it can invoke the workflow using the Activos server which is running on the same JVM as the hub server. So these are the two ways through which the Activos can be highly available. So if this node goes down, then already the client request which is coming will go to the hub server of node 2, and since I have registered the workflow with the localhost, it talks to the Activos which is running on its the same JVM, right? But But in case the registration of the workflow with localhost is not possible in the hub console, then we have a way to register the hub console with the LB URL, and then LB can send the request either to the Activos server which is running on the JVM1, or it can do it. It can send the request to the Activos which is running on the JVM2 to achieve the high availability. Now we have the process server. Now let's suppose we have the multiple hub servers installed across the JVMs, and also we have this process server either installed on the same JVM, JVM2, or it has also process server can be installed as an standalone on its own JVM, right? So first of all, for the process server to be highly available, we need to register the process server in the hub console, all the process servers, right? So obviously more than one is needed, so that if one of the process server goes down, the hub server has access to the other process servers, right, to execute the jobs, right? So now from the external load balancer, the request comes to the hub server. However, here hub server internally load balance the request across the process server. There is no need of LB between the hub server and the process server. So for example, the request comes to hub server 1. It can either send to process server JVM1, JVM2, or JVM3 to execute the actual job. Now, if the request comes to hub server 2, it can also send the request either to the process server which is running on JVM1 or JVM2 or JVM3. Right, so this is how to execute the jobs without any interruption. Even if one of the process server goes down, we have the other process servers available to take the requests, right? So now we have the infinite span clustering. So why it's needed? The infinite span clustering actually plays a major role to replicate the metadata changes, for example the repose changes, right? So whatever if you're adding any columns, or if you're changing any if you're adding a new base objects for the other node to have the same metadata available, let's say you change that, but you do the repose changes through the node 1, for those changes to be available into the node 2, it uses this infinite span clustering, right? So it does the replication across all the nodes which is in the same cluster using the by default the UDP protocol, which uses the multicast IP and multicast port to broadcast those changes to the other nodes which are part of the same cluster. Now TCP protocol can also be used if UDP is not allowed, right? So those configurations are possible. Now how do we identify that what are all the nodes which belongs to the same cluster, right? So this is the convention which is being used: the cache name, the database host, underscore the database name, master database name. So this cache name is defined in the infinite span configuration XML. The database host is basically under C repos database table under CMX system. Whatever the database host used for the master database, that's what is being used, underscore the master database name, which is CMX system. So with this particular thing, the cluster name is formed. So what all the nodes which has the same name, the changes will be replicated across the nodes. Now this database host for the master database should not be localhost. Why? Because it translates in each node with its own IP, and then each cluster name in the different nodes will be different, and the changes will not be replicated. Basically the messages would be discarded. It should be the database server hostname or the IP. So these are the cache types we have, right? So how MDM does is, we have the different cache components to store different types of objects, right? For example, we all the repose objects, repose related information is stored in the repose objects. This is the repose object cache type. Then the SAM resources, or it could be the hierarchy types, then those are stored in the data objects. Then we have a session management. So for example, when the user logs in, then all the session related information, the MDM session ID is stored in the session management cache. For the tokens to achieve, for the SIF calls, the REST calls, to ensure the pagination functionality works, we have the search token cache type. For like that, we have some other internal cache types as well. right? So we basically, these are the reason why is cache to store different information, the metadata information within. This search token and the session management, they are the runtime information which is present. And these are repose objects and the data objects, these are the metadata information. We use by default the replicated cache in the sync mode, which means all the changes which is done in one node will be replicated to the other node synchronously. Here is the InfiniSpan configuration XML file. It is basically present in the hub server resources folder, and here it specifies that what all which the JGroups file is available for both UDP and the TCP, and here you specify that the communication that we'll be using to send the messages as well as to identify the nodes in the cluster is the UDP, right? So here specify the cluster name. So this is what basically used to form the cluster name, as we discussed in the previous slides. This is one of the component that will be used along with the database host and the master database name, right? So this here we can change the name of the cluster, where it can be same for the QA nodes and it could be different for the prod nodes, so that the cluster name form would be very unique to that environment, right? So now coming back to the these are the replicate cache, right? So we were talking about the cache types. So we have CMX internal, we have data objects, we have disable when lock, we have data objects, MDM session management, repose objects. So these are the repose objects, search tokens. So these are the different replicated cache regions that we have available, and for each of them you have a remote timeout. So which means within this particular timeout, if it is not able to replicate it, it will get timed out. Then similarly we have a what's the expiration lifespan. So this is like a 1 hour. So this can be increased in the production environment where you will not be doing much changes. I mean, for the repose objects, right? For the search tokens, I think for the search token is for the pagination functionality. So you won't need the search tokens for more than an hour. So, but for the repose objects, you need to have those repose objects available for in production environment, maybe for 7 days, right? You don't want, because you won't be doing the metadata changes at all. So this can be increased the lifespan to a day or 2 days. And this expiration interval, how frequently it will check for the so every 5 seconds it checks for whether the repose objects are have reached this lifespan. So this can also be increased. So for the repose objects, data objects, this lifespan and the interval can be increased. However, for the search token, 1 hour is enough, because you want to have pagination functionality, and for this 1 hour search token in the should be available only for an hour. More than that, it doesn't make sense. Similarly, you can, like, if some of the objects, the replication objects, if you don't want it to be in the replicated cache, I mean, you don't want it to replicate, you can convert this replicated cache into the local cache, right? So that is also possible, depending on the whether what objects you want it to be replicated to the other nodes, right? So now if you see this JGroups UDP XML, this is the multicast port which MDM InfiniSpan will use to basically broadcast the messages to the other node. Now coming back to the Elasticsearch clustering, since we have multiple hub server nodes and the process server nodes which are going to connect to the Elasticsearch for the searches, we need to have Elasticsearch as well in the multi-node, right? So the Elasticsearch is installed and run in its own JVM. So that Elasticsearch also should be multiple nodes, so that in case one of the Elasticsearch node goes down, the hub server and the process server have access to the other Elasticsearch nodes for the searches as well as indexing, right? For the smart search to be highly available. So this is needed for high volume system with frequent loads, as well as to recover in case there is a failure in the disk itself, where Elasticsearch is storing the data. So we have other Elasticsearch nodes available where replicated data is available, right? So it is for both high availability as well as to recover from the disk failures, right? So this number of Elasticsearch nodes should always be odd number, right? And the minimum number of active nodes should be n by 2 plus 1 for the Elasticsearch high clustering, right? But for example, if I have 3 nodes, then if one of the node goes down, now the 2 nodes should always be up and running, right? For the ES to be able to serve the request. If 2 node goes down, then the whole Elasticsearch cluster will not be able to serve the request, because the one minimum number of active nodes that should be available all the time is n by 2 plus 1. So for the 3 node cluster, the 2 should be active at all times. For one of the node, failure will be possible, right? The reason is, if we make just one, if this minimum active nodes becomes 1, then it can lead to the split brain. So if one of the node goes down, then for each of the machines, if they are not able to locate each other, both can try to become the master at the same time, and that can lead to the index corruptions. So this odd n should always be the odd number, as well as for the 3 node cluster, this n by 2 plus 1, the 2 should be active at all times. This is a requirement from the Elasticsearch side. Now E360 application. So what are all the HA requirements for the E360 application? So if you see, the E360 application should be accessing the hub server nodes to access the composite services or the SIF calls or the REST services through the LB. Why? Because we have multiple hub servers, so LB will be able to load balance the request, as well as if one of the hub server node goes down, it has got access to the other hub server nodes, and it can redirect the request to the other hub server nodes to access the hub services. Now on the LB side, you have to enable the sticky session on the J session ID. Why? Because once the user logs into the E360 application, the first time a J session ID is generated, so to maintain the session, right? So if the LB connects after the user logs into the first node, all the subsequent requests should go to the first node to maintain the sessions, right? And then the internal MDM session ID, which stores the security credentials of the object for the users, that gets replicated using the infinite span clustering across the nodes. Now once the user logs in, and if that node goes down, it will requires the user relogin. And uncommitted changes, like if once it is connected during the operations, if the node goes down, then the data is uncommitted, and the user needs to redo that data by relogging and connecting it to the other hub server node. Now SIF and REST-based custom application. Here also LB is required for the high availability to load balance the request, as well as to, in case of one of the node goes down, we have the other hub server available to serve the request, right? So here you have to notice there is no sticky sessions, right? Why? Because it's a REST based and custom application. It's not a user based where you have to maintain the sessions, right? So if one of the request is being made from the REST application, the subsequent request can go to any one of the nodes. We don't have to maintain the sticky sessions for the SIF and REST based application. Also, if once it sends a request and it gets connected to one of the node, then during that time, if the node goes down, the REST based custom application should have a retry logic to resubmit those requests, so that it gets served by the other node. Okay. Now we have a EJB clustering. So EJB clustering, why it is needed? So like your REST and SIF based application, if it is an HTTP based, it's fine. But if the SIF based application or your composite service calls are using the EJB calls to make to the MDM to fetch the data or to update the data, etc., the high availability for the EJB calls is also needed. For that, you have to do the EJB clustering. Now, how the EJB clustering happens? The configuration is at the app server level, right? So for the standalone full HXML, if you are using the JBoss, the standalone full HA configuration already comes default with all the configuration needed to do the EJB clustering, right? And then you have on the application side, you have to use the comma separated URL. So if you are using JBoss, it has to be comma separated remote URLs. If you are using WebLogic, it has to be comma separated T3 URLs, so that if one of the node goes down, it automatically connects to the other nodes which are available, hub server nodes available to serve the request, right, using the EJB protocol. Now, once if you are clustering the EJB at the app server level, then also at the MDM configuration level, in the CMX server properties, you have to make the jboss.cluster to true, and you have to run the post on install or the repackage and redeploy the ER files to the application server, so that our MDM EJBs are also clustered and makes use of the EJB clustering feature which app server provides. Now JMS clustering, right? So why it's needed? Because MDM publishes the messages, which any changes based on the message trigger events that you have, it publishes the messages to the outbound queue. Now if you don't have the JMS clustering done, then if that node goes down, then the messages are not accessible anymore for the consuming application. So it is providing high availability for the consuming application, right? Your application which will be consuming the messages from the outbound queue. So if you have the JMS clustering setup done, if one of the node goes down, then the consuming application will have access to the messages from the other nodes, right? So again, this configurations has to be done at the app server level. Now different configuration exists. It could be like, for example, in the JBoss, it could be in standalone full HA, automatically that active server backup server configuration comes, where both the nodes can replicate, I mean can push the messages to the backup server of the other node, so that when active server goes down, you have those messages available in the backup server. So that configuration automatically, but can be done explicitly as well. Now depending on the different app servers, you have different configurations available for the JMS clustering, right? So and it is mainly for the consuming application, right? So to have the messages always available even in case of a node failure. Now coming to the disaster recovery, right? So it follows the distributed HA architecture, which is active passive. Now passive instance is always installed in a geographically distant location. Why? Because to recover from a disaster, like it could be a flood or some weather condition due to which the active instance is not available anymore, then we have a passive instance which can be activated and which will serve, which can during this disaster recovery, this passive instance will be used to serve the to access the MDM services, right? So now complete failure in the active instance, and below the configuration changes required for the DR to be working correctly, right? Once you have the, let's say you have the database replicated from the active instance into the passive instance, then under CMX system you have a CD post database. So in the passive instance we still have the old database specific information stored, so that needs to be changed to point to the passive instance database server, right? So we need to change it to point to the to update those database specific information to point to the the passive instance database DB server details, right? Similarly, in the ORS, we also have a C repos DB release. There also database specific information is stored, like connect URL and all, that needs to be updated according to the DR DB server, right? Which is we are calling it as a passive instance. Now in the data source configuration, we have a in the app server level, still like if you have copied the configuration file from the active instance to the passive instance, then the app server, the data source also contains the the active DB server details. So that also needs to be updated to point to the DR server DB server, right? And we also have the CMX server properties. So there are various properties in the CMX server where it refers to the hosts, the RMI, the host name, right? The host name, the comma separated URL hub server host name. So that needs to be updated as well according to the DR server details. And also in the build.properties we have DB URLs, the host name and the port of the Activos as well as MDM server. So that needs to be updated in case the configurations has been copied from the active instance to the passive instance. The set IP and env.sh, in case of WebSphere and all, you define the logical server name as well as the cluster name, so that if it in case it is getting changed in the DR instance, it has to be updated. Otherwise, it should be okay. You have to copy the certificate from the active instance to the passive instance from resources and certificates, right, to match it with the database. So whatever the certificates that are available in the database, if you copy it from the active instance to the passive instance, it will be in the same. Similarly, we have also in the process server the certificates available in the active instance that needs to be copied to the passive instance. So typically these are the steps that has to be done once the DR instance is set up, to keep it so that when the actual disaster happens, you will be able to recover from without any much delay. And post that, you need to make sure that you repackage the ER files and redeploy this ER files into the actual application servers for the property to take effect. Yeah, so now we'll be looking at those tables and the configuration files that needs to be changed and what was discussed in the DR steps. If you see this in the C repos database, we store this we store the connect URLs, right? So this connect URL, that host and the port host information might have to be changed when you are when the DB is copied from the active instance to the DB to the passive instance, because the DB details, the DB server host name and all will be different, right? And we were talking about the connect URLs, and the second is in the ORS we have a C repos DB release. There also we have a connect URL available, right? That also needs to be changed. Where is the So this also, the host information might have to be changed if it's changed, right, into the passive instance. The second thing is we have the build.properties, right? So in the build.properties, we store the database related specific informations, and then the app server specific, and it could be the Activos and the URLs, right? So this URL has the host information, etc., the DB details, etc., has to be changed before so that it can be specific to the passive instance, in case you copied this configuration file from the active instance to the passive instance. Secondly, in set IP and in VSH, we have the VAS server name, etc. So that also might have to be changed in case it is you're using a different name, right? And then this hub server resources certificates, this needs to be copied from the active instance to the passive instance, so that it is in sync with the DB, the certificates, the public certificates is stored in the database, right? So yeah. So now coming to the best practices, we can the first thing is you need to make sure that avoid split brain scenarios in the different situation, like for ES cluster, right? So you have to avoid by the usage of odd number of ES nodes. Why? Because if it leads to the split brain scenarios, you have a chances of corruptions happening, index corruption happening. Similarly, for JMS in infinite span clustering, if it could be odd number of app server nodes, then there will not be any split brain scenario happening in because there will always be even if the nodes communication doesn't happen, at least the two has to be available all the time if it's a 3-node cluster, and it will not lead to the split brain scenario. Now, for the infinite span, we recommend that use different set of MCAS ports in that JGroups UDP XML. For the set of QA set of nodes, use one multicast port. For the prod, you use the different multicast port than the QA, because since it's a multicast, still the QA traffic will go to the prod, and the production traffic will go to the QA nodes traffic. Although it will be messages will be discarded, but the network traffic is flowing in. Why network traffic will be discarded because the cluster name form would be different, as it involves the database host name IP, right? So there will be different cluster name, but to avoid this network traffic flowing in, use altogether the different set of multicast port for the different environments. It is recommended to perform the metadata changes, any metadata changes, especially in prod during the downtime, and then restart the nodes. Why? Because the if metadata changes are performed in the production environment directly when it is used in the business hours, then those changes will be replicated and it can impact the performance of the applications relying on it. For SIF and REST based calls uses the pagination, right? If you are using the pagination, so to get the next set of data, if the data coming is more, then we need to ensure that the search tokens are replicated, right? For this, you need to make sure that the infinite spin configuration, the communication using the UDP protocol, the multicast ports are not blocked at the network layer. If you are using the UDP, and the communication has to happen so that the search tokens are replicated. Also, the session management information is replicated. And if this is especially needed if the REST calls, since sticky sessions is not recommended, then it will always go the request can go to any one of the nodes, the subsequent request. So this search token information and the session related information is very important for it to get replicated to the other.